Hello, today we are going to discuss some of calculus's applications to economics. So let's dive right in. Let's say that we have two firms and they're competing in Cournot competition. So Cournot competition means that they're going to decide what quantities to produce in order to maximize their profit. So let's say that firm number 1 has a marginal cost of 1 unit and firm number 2 has a marginal cost of 2 units. And our demand function is 12 minus the total quantity of what is being produced. So our price is going to be dictated by our supply, law of supply and demand. So let's write out the profit for firm number 1, and we'll call that pi 1. So the profit for firm number 1 is going to be the price times the quantity that firm 1 produces. So that there is our revenue term. And now we can subtract our cost, which would just be our marginal cost of 1 unit times the quantity that firm 1 produces. And just to be clear, Q sub T is simply Q1 plus Q2. It's just the total quantity produced in the market. So similarly, the profit of firm number 2 is the price times the quantity produced by firm 2 minus firm 2's marginal cost times the quantity it produces. So these are our two profit functions, and we want to maximize those with respect to each other. So we want to know what firm 1 is going to produce given what firm 2 produces, and what firm 2 is going to produce given what firm 1 produces, and we're going to find the market equilibrium. So let's do that. So in order to do that, we're going to look at the profit functions and try to maximize them with respect to each firm's quantity. So let's do it for firm 1 first. So if we rewrite their profit function, that's their profit function. We can simplify it further because eventually we're going to have to take a derivative. Okay, so we just combined all like terms, and this is essentially the simplest form of our first firm's profit to take the derivative of. So if we want to maximize the profit, we're going to take the derivative of pi 1 with respect to Q1. Okay, now this is a little different from your traditional derivative because we're going to treat Q2 as a constant. In this case, we're going to say that firm 2 is in the market, they're producing something, that's not going to change, and we're firm 1, so we want to know what we should produce. So the only thing changing in this instance is Q1. So this derivative here is simply 11 minus 2Q1 minus Q2. So let's solve that for Q1. And if we're going to maximize it, we have to set the derivative equal to 0. So let's solve this for Q1. So Q1 equals 11 minus Q2 over 2. Okay, terrific. Let's do the same thing for firm 2 over here. So our profit function for firm 2 is that is our simplified form of our profit for firm 2. And if we take the derivative of that, now in the same way that we held Q2 constant on this side of the board, we're going to hold Q1 constant for this derivative. So if we take this derivative, we get 10 minus Q1 minus 2Q2. Alright, so let's solve this for Q2, and then we can plug it back into this equation and actually get a number. And recall this is equal to 0 because we're trying to maximize it. So Q2 is 10 minus Q1 over 2. Okay. So now we can take what we saw for Q2 and plug it into this side of the equation, and we can solve and get a number for Q1. So Q1 equals 11 minus 10 minus Q1 over 2 all over 2. So 2Q1 equals 11 minus 5 minus Q1 over 2. And plus. We get 3 halves. Q1 equals 6. And Q1 equals 4. So this is the quantity that firm 1 is going to produce in equilibrium. We can take 4 and plug it into our equation for Q2. So Q2 was 10 minus Q1 over 2, which is 10 minus 4 over 2, which is simply 3. So now we have found 2 quantities that the firms will produce in equilibrium when they're competing. Let's go through and find what their profits would be. So our Q total is Q1 plus Q2, which is just 7. So pi 1 is 12 minus Qt times Q1 minus Q1, which is simply 12 minus 7, so 5, times Q1, which is 4, minus Q1, which is 4, and that is 16. So there's pi 1. Pi 2 is going to be 5 times 3 minus 2 times 3, and that is 9. So, if we use our calculus and we use derivatives, we can maximize profits given competing firms who are competing in quantities. We could also do it for firms competing in price. However, it's really the same technique. And thank you.